Okay. Let's take a look here now at the derivative of a logarithm. Okay. So we've taken a look at the derivative of the natural logarithm, and now let's take a look at the derivative of a regular logarithm with a regular base b. Okay. The derivative of that is 1 over x, okay, that's the value in the logarithm there, times the natural logarithm of b. Okay, so the proof, if you want to look at the proof there, it's on page 380. Okay, the proof for this. But let's do a question where we're going to use this. Okay, so this is the type of question where you've got a logarithm. Okay, you've got a logarithmic function. You've got a base 10, so it's a common logarithm. But you have also this as well here, 3x plus 1 all to the power of 4, and you're asked to find the derivative. Okay. Now, I'm going to remind you of a law of logarithms that is going to make this a little bit easier for you. Okay. Because remember, if we can simplify something before we take the derivative of it, a lot of times it's going to make our life a little bit easier. So, if you look at this, who can tell me what law of logarithms is going to maybe make this a bit easier? How can I rewrite this a little different way? Exponent, thank you. Bring the exponent down. That is absolutely true. If you look at this number 4 right here, okay, if we have to do chain rule here, okay, bring that 4 down, okay, that's going to be a little something. But look at it, if we can bring that down as a multiplier there, just as a scalar in front, it's going to make our life way easier. So yes, I would agree that that's a good idea. So this is what it's going to look like. Okay, the 4 is going to be brought down in front. Oh, that's not derivative yet. That's just rewriting the function. Okay, so let's take the derivative of this here now. And this is a multiplier just up front, so we can kind of let it just hang out there for now. And let's take a look at this function. So we said the derivative of a logarithmic function is this pattern right here. So let's do that. 1 over. Now this value x goes down here in the denominator. And what's the value of x here? This one right here. 3x plus 1. And then we multiply that by the natural logarithm of the base here. So that's 1/10. Now the one thing we can't forget is that this is not just x, is it? This is really a u. So guess what we do if this is a u? The u goes there, but we have to multiply it by u prime. So we are going to have to do chain rule here, of course, multiply it by the derivative of this, which is 3. So the derivative is 12 over 3x plus 1, 1/10. No. Okay, good question. Do you have to do product rule with this 4? This is just a scalar. It's just a number. So if it was 4x, then yes. It's two kind of separate functions. But because it's just 4, no, you don't have to. You can just leave it out front there. Okay. If it was 4x, yes, product rule. Okay. Good question. Any other questions? That's a fair question. Okay. All right, so yeah, that's what you can do. Remember, make sure you take advantage of this laws of logarithms whenever you can, as like to say. You would get the same answer if you left that up there. But what you do then is the chain rule here, this wouldn't just be just 3, right? First of all, you would have 3x plus 1 all to the power of 4 down here. Then you'd have to multiply by 4 times 3x plus 1 to the power of 3, and then times 3, and this 4 would be there. Anyways, it gets a little bit hairy. Oh yeah, sure. If you want to do the long way, go ahead. Yeah, no problem. I'm just saying that this sort of thing, totally. No, that's good. Fine. No, it's a good question. If you end up doing that way and you didn't see that, and you did it the long way and you got the same answers, no problem. Yeah, no problem at all. I'm just trying to give you a little hint here. Okay, example 8. And I copied the question and the solution here onto the notes. I want to focus on a couple things here that, again, when you look at these solutions here, like in your solutions manual or Even when we do things like this, sometimes there's little steps that are skipped or assumed that you know what's happening. And so I want to just kind of focus on a few of those little things here. This one. All right, so if you're asked in this question to find the absolute max value, okay, of this function, the big picture is what you're going to want to do is you want to take the derivative, right? You want to find the critical numbers, and you want to find one of those critical numbers that would represent a maximum. And if we're talking about absolute maximum, you got to consider the domain and see if there's any endpoints. If it gives you a specified domain here, right, an interval or something, then you would have to test this start point and that end point as well and see if that yields a maximum value when you plug it into the derivative. But it doesn't in this case, and so this right here is a continuous function. There's x can equal 0, let's just kind of get into it here. Okay, so first of all, finding the derivative. If you want to make this an x to the -1 and do product rule, you can. But what they did here in this example was just do the quotient rule. So derivative of the top times the bottom minus the top times the derivative of the bottom up here, and then divided by the bottom all squared. When you multiply these two together, you get 1, and this is, of course, minus ln x. So the critical numbers occur when the derivative equals 0, and so, of course, that equals 0 when the numerator equals 0. That's kind of what our concern is. So if we let 1 minus ln x, and where is that? 1 minus ln x equals 0 here, which turns into an equation of ln of x equals 1. And remember, when you have a logarithmic statement here, an equation like this, you can always rewrite that as an exponential. So that's e to the 1 equals x, or x equals e. Okay? So again, just a couple things there. When you have ln x equals 1, that's a logarithmic equation. You can rewrite that as an exponential, and that's going to help you. So e to the 1 equals x, or x equals e. So that's your critical number, is e, 2.718 sort of thing. Okay, e. Now, this stuff down here, okay, you only have one critical number, so you could maybe assume that it's a maximum value, but, how do you check? How do you find that out for sure? Well, you could do sign analysis, right? You could do sign analysis, or you could, I guess, use a little bit of logic and realize that, hey, x squared is always positive. It could be 0, but it's never negative. So if you're looking for, this to be a maximum or a minimum, right? If you're kind of wondering, you're saying, well, the derivative here would have to equal 0, and we should check to see if the derivative is greater than 0, where the derivative is greater than 0, right? And possibly when it's less than 0. And so you got to see if that lines up. Again, sign analysis, I would suggest, would be maybe just as easy, but the derivative is greater than 0 when 1 minus ln x is greater than 0, right? And so that means that that's where ln of x is less than 1. If you change this into an inequality. And that means e to the power of 1 would have to be greater than x. See? E to the power of 1 is greater than x. So the derivative is positive when e is greater than x. And likewise, the derivative is negative when e is less than x. Okay? So you have e here, and you have positive here, negative here for your sign analysis. Right? So that represents a maximum value. Okay? Again, I just want to show you this. This is the way they kind of work it out, which is fine. I think if you did sign analysis and even just put put the factor there and x squared is positive, just find out using a test values, right? If this is where this is negative and where this is positive. Okay, so the absolute maximum value. Okay, so you plug e into here, and then you get your value. So if we right on over here to the book. Where is that? Question. What example is that? There we go. Okay, so this is right here. So on the next page then, it would be the end of it there, and so you plug in E into the equation. And of course ln of E is 1, so ln of E. That's your max value. Questions?